Picture a winter night approximately 50,000 years ago in what is now northern Spain. Temperature, -15 Celsius outside. Wind from the northwest. The kind of cold that does not just chill, it dismantles. It pulls heat out of exposed skin in minutes and replaces it with something that feels like burning. And somewhere in a limestone cave in the Cantabrian hills, a small group of people are sitting around a fire. Watching the entrance. Listening to the wind. Alive. They were not our ancestors. They were something else, something adjacent, something remarkably close, and then something completely gone. And the reason they were alive on that particular night, the reason they were alive at all, is one of the most psychologically disturbing survival stories in the history of this planet. Because they were not supposed to make it. By every biological measure available, they should have been extinct hundreds of thousands of years before that fire-lit night in Spain. They were not the fastest. Not the sharpest. Not the most connected. They were, in almost every physical sense, outmatched by the world they were living in. And they survived it for 400,000 years anyway. This is the story of how. The first thing to understand, and this changes everything, is that the Ice Age was not a single event. It was not one long winter. It was a series of catastrophic climate swings, each one reshaping the continent. During the 400,000 years that Neanderthals existed, glaciers advanced and retreated dozens of times. The tree line moved hundreds of miles in either direction within a single human lifetime. Valleys that supported dense woodland in one generation became open frozen steppe in the next. Scientists call these abrupt oscillations Dansgaardoshker events, sudden lurches in climate recorded in ice cores from Greenland that show temperature swings of 10 degrees Celsius occurring over decades, not centuries. Not millennia. Decades. For a Neanderthal group with a lifespan of 30 to 40 years, a climate shift that unfolded across a single generation would have felt like the world ending and being replaced by a different, colder, less forgiving world. And then sometimes doing it again before the first shift had been fully absorbed. This is the context that makes the Neanderthal survival story genuinely extraordinary. They were not weathering one bad winter. They were surviving a world that repeatedly and violently reorganized itself around them, repeatedly killing the prey species they depended on, repeatedly collapsing the vegetation, repeatedly closing the valleys and passes they had spent generations learning to use. And they kept finding a way to be there on the other side. Let us start with the body, because the Neanderthal skeleton is one of the most misread objects in the history of science. The first researchers who examined Neanderthal bones in the 19th century looked at the heavy brow ridge, the robust build, the dense musculature, and concluded, primitive. Brute. Less than. They were not reading the bones correctly. They were projecting. What those bones actually show is an engineering solution to one of the hardest problems in mammalian physics. How do you keep a warm body alive in a world that is actively trying to take its heat? The Neanderthal skeleton is the answer to that problem expressed in calcium and collagen. Bergmann's rule, a principle documented across warm-blooded animals, states that animals in colder climates tend towards larger, more compact bodies. A larger body has more volume relative to surface area, and surface area is where heat escapes. Allen's rule adds the companion observation about limbs. Shorter arms and legs mean less surface area at the extremities, which are the places most vulnerable to rapid heat loss. Neanderthal skeletons follow both rules with a precision that tells you these were not accidental features. They were the product of hundreds of thousands of years of cold climate selection, a body that had been slowly optimized, generation by generation, for exactly the conditions it was living in. Their bone density was extraordinary by modern standards. Their muscle attachment points, the places on the bone where muscles anchor, were dramatically larger and more pronounced than in anatomically modern humans, indicating a level of muscular development that would have been remarkable even among today's elite athletes. Researchers studying Neanderthal injury patterns found that the distribution of healed fractures, the places where bones had broken and mended during life, closely resembled the injury profiles of modern rodeo riders. Not soldiers. Not miners. Rodeo riders. People who make a living being thrown into violent contact with large, forceful animals. This was not a body shaped by accident. This was a body shaped by 400,000 years of sustained violent contact with an environment that did not forgive weakness. And it was still not enough. Because no body, however well engineered, survives a winter through biology alone. At a certain temperature threshold, and the Ice Age regularly crossed that threshold, the difference between surviving the night and not surviving the night is not about bone density. It is about what surrounds you when the temperature drops. In Wonderwork Cave in South Africa, archaeologists found the oldest confirmed evidence of controlled fire in the human record, dated to approximately 1 million years ago. Burned bones, layered ash deposits, the unmistakable signature of a fire that was built and maintained in the same location repeatedly over a very long period. But fire in the Neanderthal record is not merely the continuation of this ancient habit. It is something qualitatively different. It is fire understood as infrastructure. Structured hearths, organized fire sites, circular in form, built on cleared flat stone, positioned within sheltered spaces, appear at Neanderthal sites across Europe and the Middle East over a period of hundreds of thousands of years. Kebra Cave in Israel. Spy Cave in Belgium. Salzgitter Lebenstädt in Germany. Baume-Bonn in France. These are not isolated data points. They are a pattern. A pattern that says this species had fully integrated fire into the physical logic of daily survival. But here is what is consistently underdiscussed about Neanderthal fire use. Warmth was only one of its functions. Possibly not even the most important one. Light made the interior of caves usable. Without fire, the useful space of a limestone cave extends a few meters from the entrance, the rest is absolute dark. With fire, the entire space becomes available for sleeping, for tool making, for social activity, for the processing of food. The effective living space available to a group increased dramatically the moment a fire was introduced into the interior, and the evidence of Neanderthal occupation extending well into cave interiors suggests they were using that extended space routinely. Cooking changed nutrition in ways that compound over generations. Cooked protein is more bioavailable than raw protein. Cooked starch is more efficiently metabolized than raw starch. For a body already running an extremely high metabolic demand, researchers estimate Neanderthal caloric needs during active winter conditions at 4,000 to 5,000 calories per day. The difference between cooked and uncooked food was not a quality of life improvement. It was a survival margin. Then there is the most psychologically interesting use of fire that the Neanderthal record shows: thermal alteration of stone tools. Certain raw materials, flint, chert, change their fracture properties when heated before being worked, becoming easier to shape into thin, sharp cutting edges. There is evidence that Neanderthal toolmakers were deliberately heating stone before working it. They were not accidentally warming rocks near their fires. They were using fire as a processing step in a manufacturing sequence, a step that required understanding what the heat was doing to the material and why. This is not opportunistic use of a natural phenomenon. This is chemistry. Empirically arrived at, practically applied, and transmitted to the next generation who did it the same way because someone had shown them it worked. Managing fire under Ice Age conditions was not simple. Wood was scarce in the most glaciated environments, and there is evidence of Neanderthals burning bone, specifically marrow-rich bone, as fuel when wood was unavailable. The practical reality of keeping a fire alive through an Ice Age night, keeping embers from dying, carrying coals in a hide container when moving, reading the weather to know when starting a fire from scratch was even possible, required planning across timescales of hours and days. Someone in the group had to manage this. It was a role. A function. A form of expertise that had to be learned and taught. Fire management was social infrastructure as much as physical technology. The image of the cave-dwelling Neanderthal, huddled in the nearest available dark opening, grateful for whatever shelter chance provided, is one of the most persistent misrepresentations of the archaeological record. When researchers map the locations of Neanderthal occupation sites against the reconstructed landscape of the periods in which they were occupied, the pattern that emerges is not random. It is deliberate. Specifically, purposefully deliberate in ways that reveal something important about how these people thought about their environment. South-facing exposures appear in the Neanderthal site record with a frequency that cannot be explained by chance. In the northern hemisphere, a south-facing slope or cave entrance receives significantly more direct sunlight across the winter day. When the sun tracks low across the sky, the difference between a south-facing and north-facing site of the same elevation can be several hours of additional solar warming. Neanderthal site selectors appear to have known this. They appear to have factored it into every decision about where to camp. Windbreak positioning shows the same deliberate logic. Sites positioned behind natural ridges, tucked into valley bends, sheltered by rock formations from the prevailing wind direction appear repeatedly in the record. In a periglacial environment where cold wind off glaciated uplands was a constant winter factor, position relative to wind was not a preference. It was a matter of survivable versus not survivable. Water access, gain corridors, flint outcrop proximity, all of these variables appear in the distribution of Neanderthal sites with a regularity that points to systematic assessment rather than opportunistic choice. These were not people who stopped wherever they were when the light faded. They were people who knew their landscape well enough to have developed an implicit hierarchical weighting of what mattered most in choosing where to spend the night. At some open-air Neanderthal sites, places without the natural shelter of a cave, researchers have found spatial distributions of stone tools and animal bones consistent with organized living space. The site of Moldova in Ukraine shows evidence interpreted by some researchers as a structure built from mammoth bones, a ring of large bones that may have supported a hide covering. The interpretation is contested, but it is not dismissed. And it points towards something that the cave-dwelling image obscures: Neanderthals did not simply find existing shelters. In at least some contexts, they may have built their own. Fabric does not fossilize. Hide does not fossilize. Thread does not fossilize. The direct evidence for Neanderthal clothing does not exist in the form of garments, it exists in the tools used to make them, and in what microscopy has found on those tools' edges. Scrapers are among the most common implements found at Neanderthal sites across their entire geographic range and entire temporal span. Scrapers are designed to remove fat, membrane, and connective tissue from the inner surface of an animal hide. That is what their morphology and their wear patterns point to. And wear pattern analysis, the microscopic examination of how cutting edges have been modified by use, tells you what material a specific tool was worked against. Hide produces a distinctive polish on stone edges. Studies of scrapers from multiple Neanderthal sites across Europe and the Middle East have confirmed hide working wear patterns in large numbers of tools, separated by tens of thousands of years and hundreds of miles of geography. Residue analysis has added another layer. Traces consistent with animal fat and protein, the residue of processing fresh hides, have been identified on scraper edges at several sites. And at some sites, pointed bone tools capable of piercing hide have been found alongside the scrapers. Here is the darkest fact in the Neanderthal clothing story. One analysis of Neanderthal skeletal remains found cold injury evidence healed during life, frostbite traces in the bone structure of extremities in individuals who survived the injury. Despite all the physiological cold adaptation. Despite the barrel chest and the short limbs and the fat reserves. Despite the fire and the caves. Some Neanderthals still got frostbitten and lived with the damage for years afterward. Because the body alone was not sufficient. And the clothing they had, hide wraps, draped and secured, probably not sewn into fitted garments with the precision of later modern human technology, was good but not perfect. It kept them alive. It did not make them invulnerable. The difference between a draped hide and a sewn fitted garment matters in practical terms. A draped hide wraps well in still air. It fails against wind at its gaps. It loses insulation efficiency when wet. A sewn fitted garment seals against wind and retains insulation across a wider range of conditions. Early modern humans arriving in Europe approximately 45,000 years ago were producing fitted sewn clothing using purpose-made bone needles and sinew thread. This technological difference, not in intelligence, not in culture, but specifically in how well a garment fit and sealed against the wind, may have represented a genuine performance margin in the coldest conditions the two species shared. The Mousterian tool tradition, named for a rock shelter site in France where these tools were first formally described, is the archaeological signature of Neanderthal presence. It appears across their entire geographic range, from the Atlantic coast to Central Asia, across approximately 300,000 years. That span and that consistency are the first things worth examining, because they are telling you something important before you even look at the tools themselves. A technological tradition that persists across 300,000 years and a geographic range of several thousand miles is not an accident. It is a transmitted discipline, a body of knowledge that had to be taught by one person to another, refined across generations, adapted to local materials while maintaining its core logic. The Mousterian existed because Neanderthals were teaching each other how to make it. That is the only mechanism that produces that kind of temporal and geographic consistency. At the center of the Mousterian is prepared core technology. The Levallois technique in its most refined form involves shaping the outside of a stone core, removing preparation flakes in a specific sequence, before attempting to remove the final usable flake. The preparation work creates a geometry such that a single precisely placed strike detaches a large, flat, sharp flake of predictable size and form. What this requires, before the toolmaker touches the stone, is the ability to look at a raw piece of flint and mentally project the finished flake they intend to produce. The preparation work is three-dimensional planning executed in advance of the result. The efficiency implications of this are not abstract. In a winter landscape where good quality flint was not always nearby, where carrying heavy loads of stone imposed real physical costs in cold that was already extracting enormous metabolic energy, the ability to extract maximum cutting edge from minimum raw material was a direct survival advantage. A toolmaker who could produce more from less was a toolmaker who could travel further, carry lighter, and still arrive at camp with a functional toolkit. Hafting, attaching a stone point to a wooden shaft to create a spear, adds another dimension. Chemical residue analysis of Mousterian tools has identified traces of birch bark tar used as adhesive for hafting. Producing birch bark tar requires sustained, precise temperature management, controlled heating of birch bark in conditions that must be maintained within a specific range to produce the usable adhesive. This has been experimentally reproduced and found to require real attention and practice. It is not gathered from a tree. It is manufactured through a process that requires understanding cause and effect at a chemical level, even if that understanding is empirically derived rather than theoretically described. The Neanderthal toolkit has been persistently described in popular accounts as cruder, simpler, less sophisticated than the tools of modern humans. This comparison does not survive serious examination. What it actually reflects is the difference between a technology evaluated by its resemblance to what came later and a technology evaluated by what it allowed the people who made it to do. Neanderthals with Mousterian tools survived dozens of glacial cycles across a range of several thousand miles for 300,000 years. That is the benchmark. By that benchmark, the tools worked. The old story was that Neanderthals were primarily scavengers, opportunistic thieves at the margins of other predators' kills, incapable of the planning and coordination that real hunting requires. That story has not survived contact with the evidence. The faunal record at Neanderthal sites shows prey specialization, the repeated, consistent targeting of specific animal species across time at specific locations. Reindeer sites show reindeer at every occupation level. Horse sites show horse. This is not the signature of opportunistic scavenging, which produces varied, unpredictable assemblages depending on what other predators happen to kill nearby. This is the signature of hunters who knew their prey, who understood the seasonal movement of reindeer herds, the valley crossings horses used predictably, the specific topographic features that created natural bottlenecks where animals could be intercepted. The butchery evidence is systematic and knowledgeable. Cut marks on prey bones from Neanderthal sites correspond precisely to the major muscle attachment points, the places where a knowledgeable butcher would work to strip maximum meat from a carcass as efficiently as possible. Long bones show the spiral fracture patterns of intentional breaking to access marrow, appearing consistently on bones from which surrounding meat had already been thoroughly removed. This is a processing sequence, flesh first, then marrow, the ordered approach of someone extracting maximum caloric value from a kill and doing it in the most efficient sequence. The skeletal trauma record of Neanderthal individuals themselves is the most intimate evidence for what hunting actually cost. The distribution of healed fractures in Neanderthal remains closely resembles the injury profiles of modern rodeo riders. Upper body, head, and neck injuries predominate, exactly the pattern you would expect from repeated close-range contact with large, powerful, often panicking animals. Some of these injuries were severe. Crushed vertebrae. Healed skull fractures. Arm injuries that left lasting deformity. Every healed injury in that record is simultaneously evidence of two things. First, that the hunting was genuinely dangerous, not cautious opportunism but sustained violent engagement with animals that could and did injure the people hunting them. And second, that those injured individuals were kept alive through their recovery by someone else. A healed serious injury is proof of care. You cannot heal a crushing arm fracture in a periglacial environment without food, warmth, and protection from the elements during the weeks or months of recovery. Someone provided those things. Someone chose to. For most of the history of Neanderthal research, the dietary story was simple: they ate meat. Large mammals, hunted with spears, butchered at kill sites. The isotope evidence from Neanderthal bones, high nitrogen, 15 values consistent with a diet dominated by animal protein, seem to confirm this. And it was used to construct a portrait of obligate carnivores, Ice Age meat specialists incapable of the dietary flexibility that characterizes modern human foragers. That portrait has been systematically dismantled by dental calculus. Calculus is the mineralized plaque that forms on teeth and traps whatever passes through the mouth: starch granules, plant fibers, protein fragments, the microscopic signatures of everything eaten. And when researchers began analyzing Neanderthal dental calculus with modern microscopy and biochemical methods, they found things the bone record gave no hint of. At Shanidar Cave in northern Iraq, calculus analysis revealed starch granules from wild grasses and legumes. At El Sidrón in northern Spain, calculus from several Neanderthal individuals contained evidence of bitter-tasting plants, yarrow, groundsel, and something consistent with woody nightshade. Plants with no significant caloric value that may have been used medicinally or as self-treatment for infection or pain. At Spy Cave in Belgium, dental calculus showed starchy plant consumption alongside woolly rhinoceros and wild sheep. The dietary picture that emerges is not of obligate carnivores. It is of flexible, knowledgeable foragers who were drawing on a wide range of resources, animal and plant, large and small, with a sophistication that the bone record alone systematically obscured. The bone record is biased. Bones preserve. Tubers do not. Nuts do not. The absence of plant evidence in the faunal record was never evidence that plants were absent from the diet. It was evidence that plant matter does not fossilize. What the calculus evidence adds to the hunting evidence is something crucial for understanding how Neanderthal groups actually survived winter: dietary flexibility. A group that ate reindeer when reindeer were available, tubers and nuts and shellfish when they were available, and bitter medicinal plants when something in the group needed treatment, that group was running a survival strategy far more resilient than the single prey hunting model suggested. It was not one strategy or another. It was all of them simultaneously, applied with the knowledge of when and where each resource was accessible. That knowledge accumulated within groups. It was not reinvented by each generation. It was taught. Cold does not favor solitary living. This is not a sentiment. It is an ecological fact. In warm, resource-rich environments, a sufficiently capable individual might survive alone for stretches of time. In the periglacial environments Neanderthals occupied, where winter required maintained fire, processed food, insulated sleeping surfaces, and sustained warmth across nights that could be lethally cold, a single person could not sustain all of that simultaneously. The cold selected for cooperation with a pressure so relentless that groups unable to sustain the social structure required for collective warmth simply did not make it to spring. The care of injured and disabled Neanderthals is the most discussed and most emotionally powerful evidence for the social structure that made survival possible. The Shanidar, one individual from Iraqi Kurdistan, is the most cited case. This was a male who survived to middle age, approximately 40 years old, in a species where most died before 30, despite injuries that included a crushing skull fracture on one side, a withered and functionally useless right arm, and probable vision loss in one eye. The long healing of these injuries is documented in the bone. He survived for years after they occurred. He could not have survived alone. Someone fed him, protected him, kept him warm. Not once. For years. Similar cases appear across the Neanderthal record. Older individuals with severe dental wear and arthritic joints who lived on past the point where they could have fully contributed to hunting or foraging. Their survival past functional productivity is evidence that Neanderthal groups were not operating on a strict cost-benefit calculus of individual contribution. They were doing something that has a specific and important name in evolutionary biology: reciprocal altruism. Caring for the individual who cannot currently contribute because the group has internalized, through generations of selection, through learned social norms, through whatever constituted culture in the Mysterian world, the understanding that this is how the group survives collectively even when it costs them individually. The oldest members of the group who appear healed and cared for in the skeletal record were not merely recipients of charity. They were, almost certainly, the primary holders of accumulated landscape knowledge. Where water was reliable in dry summers. Which valley held horses during the autumn rut? Where the good flint outcrops were, 2 days' travel north. Which bitter plant reduced swelling in an infected wound? That knowledge, the thing that made the next winter survivable, lived in their experience. Keeping them alive was an investment in the group's future competence, not just a social gesture. The cold made that calculation visible. Groups that understood it survived. Groups that did not left smaller herds of bones for us to find. The Neanderthal disappearance from the fossil and archaeological record, concentrated roughly between 45,000 and 40,000 years ago, is not the dramatic extinction event that popular culture has made of it. It was not a battle. It was not a plague we can identify in bone chemistry. It was not a single winter that finally proved too cold. Neanderthals had survived dozens of winters that cold. The cold was not new to them. They were, by any reasonable biological measure, better adapted to that cold than the modern humans who were arriving in their range from Africa. What was new was the modern humans themselves. The genetic evidence is now settled in its broad outlines: Neanderthals and Homo sapiens interbred. Every person alive today whose ancestry traces outside of sub-Saharan Africa carries somewhere between 1 and 4% Neanderthal DNA. That is not contamination or statistical noise. It is the measurable record of encounters between the two species that produced children who survived, reproduced, and whose descendants eventually carried a mixed ancestry across the entire non-African world. In a meaningful biological sense, the Neanderthal story did not end. It was incorporated into another story. The one currently reading this. The mechanism of replacement, whatever it was slow. The overlap between the two populations in the same geographic range lasted thousands of years in some regions. The last known Neanderthal populations held on in the geographic refugia where their predecessors had always retreated during climate stress: the southern Iberian Peninsula, Gibraltar, possibly isolated locations in the Caucasus. They were doing what they had always done, contracting to defensible ecological positions, maintaining their toolkits, hunting the same prey, sleeping at the same south-facing sheltered sites their predecessors had used. The cold had not beaten them. The climate had not beaten them. 400,000 years of ice had not beaten them. What ended them was the arrival of a population with larger exchange networks, faster cultural transmission, possibly more effective cold weather clothing, and a slight but consistent demographic advantage that, compounded over thousands of years in a resource-stressed landscape, produced an outcome that in the archaeological record looks like disappearance but in the genetic record looks like absorption. The Neanderthal contribution to modern human genomes includes immune variants, skin and hair characteristics, and metabolic adaptations suited to high latitudes and cold environments. These were not neutral passengers. Some of them were retained by selection because they were useful in exactly the environments where Neanderthals had spent 400,000 years developing them. The people who replaced Neanderthals in European Ice Age landscapes did so partly with Neanderthal biology already incorporated into their own. Here is the psychological fact worth sitting with. The thing that ended Neanderthal independence was not the cold. It was another version of us. And the thing that made Homo sapiens capable of surviving in the environments that Neanderthals had spent 400,000 years adapting to, was partly Neanderthal. We carried them with us when we replaced them. We needed what they had built. And we did not know it. If you are walking anywhere cold right now, if you have ever felt the specific particular quality of cold air on a winter night and understood, even briefly, that without shelter and heat and the social infrastructure of other people, you would not survive it, you are experiencing the oldest fact in the human survival story. Neanderthals understood that fact, at the level of the body and the group and the accumulated knowledge of generations, better than almost any species that has ever existed. And they did it for 400,000 years. We have been here for 300,000. We have barely started. If this changed how you think about what we are and what came before us, drop a comment. Tell me which moment in this story hit hardest. And tell me where in the world you are. This channel exists for people who want to understand not just what we are, but what it costs to become it. See you in the next one.